right, guys, ready? Now, again, this is not my favorite thing to do. If I stand up here and I say, this is how to do the problem, the only one that's getting better at it is me. And I don't need to get better at it because I've been doing it for a lot of years. But I want to make sure you have the right answers, and I also want to move on with the day. Are you ready?
Yeah.
All right. So what are you given? Tell me what you're given. Oh, my girls were here. You can clearly see my girls were here. So what are you given? Are you given a graph? Which graph are you given? Position graph or velocity graph? Well, you're given both. You're given both graphs, but which one has the lines in it?
Position.
The position graph, right? So how many seconds are we talking about? 1, 2, 3, 4, 5 seconds?
Yeah.
That's time in seconds. 1, 2, 3, 4, 5. And then what does the position go up to? 5 position also? 1, 2, 3, 4, 5. So this is the position. Now it probably says X. It probably says X for position, but the X means position. I know it's confusing. We're just going to get over it. Is that all right? All right. Because it's a position graph, I'm going to do it in red. Okay. What's the position at time 0? Look at the graph. What's the position at time 0? 0. What's the position at 1 second? Oh, I didn't do 1 second. Is this 1, 2, 3, 4, 5? Okay. So what's the position at 1 second? You said it's 2. And what about at 2 seconds? 4. What's the position at 3 seconds? It's still 4. That's right. Then what? 4 and then 4. Oh, missed it. Let's just pretend. What's that?
Not too straight.
I know. It's all right.
We lost
Myself.
touch.
No, it's momentary hiccup. Momentary hiccup.
It's a Monday.
Is this the graph?
Yeah.
Fantastic. Now, tell me about this. Look at this part here, this first section. For every 1 second, how much does the position change? It changes by 2. Another second, it changes
3.
another 2. Right? 1 it goes to 2, 2 it goes to 4. Is that cool? You guys okay with that? So what I'm going to do now is I'm going to try to graph the velocity. Okay? I'm going to try to graph the velocity. 1, 2, 3, 4, 5. This is the time in seconds. This is the velocity in meters per second. Right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 4, 3, 2, 1. There you go. Let's do it in green. How do you figure out the velocity if you're given the position graph? This is the most important thing. How do you find the velocity if you're given the position graph? If you want to go from position graph to velocity graph, you're looking at the slope. Okay? So I would draw that right on there, right? Draw a little arrow, write slope over the top. This is how you go from position to velocity. You analyze the slope. Are you ready? Look here. Are there 2 distinct lines here? Does each have its own slope? Totally, which means we're going to break it up into 2 sections. We're going to get the slope of this one and the slope of this one. Are you ready? What is the slope of the first section? What's the slope of the first section? One of the things you want to be able to do, just as a general concept, is calculate the slope. To calculate the slope, take the endpoints. It is 2. Okay? You're going to take the endpoints, and you know the slope. Okay? Our concept of slope is the vertical change divided by the horizontal change. Now, you can call this rise over run, vertical divided by horizontal change. You can call it y divided by x, or y2 minus y1 over x2 minus x1. However you calculate it, this is a skill that I would like you to have as a general person in the world. Okay? So, what's my vertical change? It goes from 0 to 4. What's my vertical change?
2.
Well, it's going to be 2. We're going to do the whole thing first. Okay? So it goes from 0 to 4, and then how much is my horizontal change? 2. Now, if you're paying close attention, you're going to notice this. This is 4, what are the units on that?
Meters.
It's 4 meters, right? Divided by, what are the units on the 2? So what's my slope then? 2 meters per second. So, if the slope is 2 meters per second, then what's the velocity value? It's 2 meters per second. But here's the question. How much time does it last? How much time does it last? It lasts for 2 seconds. So I know the value is 2, and it lasts for 2 seconds, so I'm going to draw it. Hit me.
What's it?
No, go ahead.
I was just wondering what it said under vertical.
Oh, it says horiz.
Oh.
I'm sweating. I'm sweating. Can you open up the window?
Yeah.
I suppose.
I'll do this right here.
It's freezing.
It's cold in here?
Yeah.
I'm literally, I can feel like sweat like dripping.
We have one that's soup. Maybe if you took it
I love Kyla. She's like, you do realize you're wearing like a whole suit, right?
Yeah.
All right. I like that jacket. All right, so what happens then? Let's take the slope of the next section. Now this is cool, okay? When we do this next section, what do you notice about these two endpoints? What's the vertical change between these two endpoints? There's no, 0, right? There's no vertical change. So if your vertical change is 0, then what's your slope value? 0. So then what's your velocity value? It's 0, and how much time does it last from? From 2 to 5 seconds. Where's that graph? Right here. And then we can just go like this. Yes, no, or maybe?
Yes.
It's super easy when I do it. It's super, super easy when I do it. Because you're like, oh my God, that seems so easy. And then you go to do it by yourself, you're like, I have no idea what's going on. That's because me showing you how to do it doesn't really help that much. Okay? All right, here we go. What's it smell like?
Chocolate.
Is that the chocolate mint? It's solid.
It's just chocolate.
Solid. All right, so this looks good to me. One of the things we have to do is try to figure out what the change in the position is. All right, so let's do the change in position. What is the initial position? What's the initial position? 0. At 5 seconds, what's the final position?
4.
It's 4, and then here we just say, well, what was the change in position? Remember, to do the change in the position, you do the final position, subtract off the initial position. 4 minus 0 is 4. And what are the units on the position change? What are the units? How far did your object go? 4 meters.
Oh, I was a conscious there.
You all right?
Yeah.
Okay. Ethan, second, 9:45. Is that cool? And then here's the last part. Here's the last part. We know that if you just look at the change in position on the position axis, you can get it. But we also learned last week that if you shade this area here, is that also the change in the position? It should be, if you did it right. So the change in the position is the area. All right. What kind of shape is that?
Square.
It's a square or rectangle. Okay, it's a square or rectangle. How do you find the area of a rectangle?
Base on side.
Base times height. Okay? All right. So what's the height? 2 what?
Meters per second.
It's 2 meters per second. And what are we multiplying? What's the base here?
2 seconds.
2 seconds. And what 2 times 2 is? 4. And then we talked a little bit last week about how, like, magically, if you have like one thing over the other, they magically disappear. So the seconds can magically disappear, and what are you left with? 4 meters. Is that the change in the position that we expected? Does it match this one over here? How's that look?
Great.
Is that okay? Again, super easy when I do it. I want to make sure the pig wasn't in the way. Are we done here? Everybody got this? Can we move on with our lives?
Oh, yeah.
Yes? All right. I'm ready to move on. Oh, that runs a little smeary. We're going to skip the second one. We're going to go to the third one because the third one's more interesting to me. All right, let's do it. What's the position at time 0? Look at the graph. What's the position at time 0?
2.
It's 2. What's the position in 1 second?
3.
3. 2 seconds?
4.
4. 3 seconds?
2.
2. And 4 seconds? 0. That's not too bad. That's not too bad.
Just make the points big. So they go.
Just make the points bigger. It's fine. It's fine.
That's what I do.
How's that look? Is that good? You guys okay with that? So now, what we're going to do is we're going to see if we can graph the velocity given the position graph. How are we going to get the velocity values if given the position graph? That's right, we're finding the slope. That's right. So we're going to go like this. Whoop, whoop, whoop. Slope. All right, let's do some slope action. How are we going to figure out the slope for the first section? I'm going to take the endpoints. I'm going to do vertical divided by horizontal. So the slope is equal to, all right. Okay, what's my vertical change? It goes from 2 to 4. My vertical change is 2 meters. What's my horizontal change? 2 seconds. What's that then? 1 meter per second, which means that for every additional second, it travels an additional 1 meter. Which totally makes sense because it was at 2, then it was at 3, and then it was at 4. For every additional second, it travels an additional 1 meter. Is that cool? What about the other section? Oh, so let's graph that. So it's 1, and how much time does it last for? 2 seconds. Is that cool? Now, what about this section though? What's the slope of that section? What's the vertical change this time?
4.
So the vertical change, if you notice it there, is it going up or coming down on the graph?
Going down.
It's going down, so what's the vertical change?
-4.
It's -4, so it's -4 meters. And how much time is that happening? 2 seconds. So what's the slope of this section? 4 or 2, still a 2. I know, sometimes our brain does that, it flips it upside down. So this means that the velocity was -2, which means for every additional second, it moves left an additional 2 meters. So I'm going to go do the velocity, and that lasts from 2 to 4 seconds. So from 2 to 4 seconds, my -2. And then if you like, you can connect these with a little dotted line. There you go. How's that look? Super easy when I do it. Super easy when I do it. Are you ready? We need to figure out the change in the position. Are you ready to figure out the change in the position? Well, to get the change in the position, we have to do final position minus initial position. What is the initial position? What's the initial position? It's 2, right? What is the final position? So at 4 seconds, what's my final position? It's 0, right? So then what is the change in the position? Check your neighbor on this one. This is a little bit more challenging. Check your neighbor, see if your neighbor knows. What's the change in position on this one? What do you think the change in position is? Is it 2? I don't think it's 2. It seems like it's 2, but it's not. What is it?
Negative 2.
It's -2. And here's how we know for sure. The final